we're super excited to be here because we haven't done this in-person thing in a long time, and so super happy to be here. And hopefully it's what you want. I mean, we didn't come up with a lot of slides or stuff like that. We had, in fact, this is like one of the 2 slides I think we have. So we just want to show some cool demo. Our thing is we all work on cloud native at Microsoft. So let me introduce my group here. I'm Scott Hunter, VP of Product in the Azure Developer Experience team. I've got Brady Gaster over here. He's a product manager on the .NET team, specifically focusing on ASP.NET. And I've got Kendall here.
Hello.
And she is a product manager on Azure Container Apps, which we're going to talk about today. Woohoo, yeah.
Yeah. Make some noise. Yeah. Okay, lots of love. That's good.
And so we're going to talk about a couple of just high-level things, which is, it's like, is .NET cloud native, and how do you run .NET at scale in the cloud? And I'm going to kind of kick off and show a couple things you might not be aware of. Brady's going to come in and then really scale it up and really show you how you can use this stuff in Azure Container Apps. And then you're going to come in and show us Dapper.
I'm going to show you whatever I can get working. Woo! No, I'm just kidding. Yeah, it's going to talk all container apps, lots of Dapper. Super excited.
So it should be fun. So with that, let's get started.
Go.
Okay. We will close the PowerPoint down. Don't need that anymore. So it's interesting when I think of cloud native. I think of building these apps that scale really well. And as somebody that worked on the .NET team, for my history, I worked on .NET from 2007 to last year, and drove a lot of the new .NET Core work that we've done. And as a team, we all sit around and think about we've done all the right things to make .NET ready for cloud, but we don't really turn any of it on by default. And in many cases, customers aren't even aware of some of these things. And so I'm going to show a couple of things here before Brady comes on and does some really crazy stuff. And the first one is one of the things that I don't know if Donovan mentioned, one of the things that Dapper does is it allows you to actually have retry policies put on all your API calls. That's the first thing that should happen in the cloud, is you should be retrying any of your calls because they might fail. I mean, the cloud's a big thing, and there's networks and all this kind of stuff. And so your apps need to be resilient and ready for this. And so I've got this amazing app called the Fail API. And what I've done is I'm going to start here and just click it, and I will do a debug without debugging. And this is basically a API which failed right when I ran it. And so if you look at my code, what I did is I created this really cool class, and this is something that we're thinking about putting in .NET in the future. So .NET 8 might have some of this tech just built in. Notice I've got what I call it random failure middleware. What this does is randomly makes an API call just die. And then what we do is up here in the application, I'm going to wire that into my app right up here. And so now my API just doesn't work all the time. And so you can see if I F5, sometimes I get the weather, sometimes I get the weather, sometimes I get a failure. We should build this into all .NET because you should be building apps that are resilient against these types of things. So if I go and then run a client, I've got a Razor client right here, and I run this, it's going to do kind of what you expect. Oh, it failed, and I retry it, and it worked. And so how can we fix the app to be resilient to these types of things? One of the things that Donovan showed was Dapper, but we don't want to require you to hook yourself into Dapper if you don't want to. If you want to, great. If you don't, you shouldn't have to. And we actually built tech all the way back in .NET Core 3 to solve this problem. So if I come back to my app, let's go back to the source code. I'll jump into the Razor app here. What I've done, it's a regular minimal web API. If I scroll down into the, come on, let's jump over here. I'm actually where I want to be. I'm in, I'll bring the page up. You can see inside the page, I go create an HTTP client factory. I go and ask for one. It gives me a client factory so I can make an HTTP call. I'll make the call. Imagine every place you make a call, you have to go change that code to deal with that failure. That would be terrible. And so we added a feature way back in the day that we don't talk about anymore, and that's one of the things we as a team are going to try to get better at, is talking about stuff. All I've got to do is notice I have builder.services.add HTTP client. That's how that code was able to go ask for an API and get a copy of HTTP client. But I'm using a library here at the top of the screen called Poly. And all you've got to do is reference Poly in your application, and then I can change this code. And notice that I say .add transient HTTP error policy, retry async 6 times. And what this means is, hey, if it fails, keep trying a couple times. And I'm showing the easiest case of this. We have an article. Let's go to the browser. We have an article that talks all about this, and I'll show the URLs later in the talk. That talks about how you can use this tech to do backoff. So it's like try something, wait 2 seconds, try again, and make your app more resilient. So let's close down that version of the app that I had running there, and let's make sure I really close it down. Yep, that's the one. And I've added this line of code to the application, and so let's start it up again. And so with that new policy added, my app's going to be resilient to this. We have tech in .NET as well for Entity Framework that does the same thing. And so notice now, I can keep running the app, and I'll never see a failure because we built this logic into the app to do these retries. This is the part of building cloud-ready and cloud-native applications, is hooking these types of policies up. So that's showing that. Let's show something else now. Now, we mentioned before, as the folks were on the stage, we talked about container apps. And so container apps, super exciting feature that I'm really excited about. We hear from customers want to run on Kubernetes. And so at Microsoft, we want to make it easy for you to run Kubernetes. You can run AKS, that's our managed Kubernetes, but we just introduced at Build in May of this year, Azure Container Apps. And so Azure Container Apps lets you run your containers on Kubernetes, but we're going to manage all the Kubernetes for you. You can set your scale-up policies and all this kind of stuff behind the scenes, and you don't have to worry about all the intricacies of Kubernetes. If you want to get out of Kubernetes, we're going to have an export feature in the future where you can actually export your application from Azure Container Apps into AKS as well. So we want to make sure you're not making a decision that you're locked into. And so what I want to show now is, you would hope that you could just take your .NET app and run it in Azure Container Apps, and it would be great and work. So I've got an app that I built here. And I'll click the URL to open it up. It's a simple ASP.NET Core application, and it kind of searches GitHub. So I can type Azure in, and I can press search. Gets me some results back. I'm going to press search a bunch of times. This application is running great. Now I want to go scale this application up. So I'm going to go in here, and this is my container app, and I am going to scroll down to scale. Portal, okay, and I'm going to edit and deploy this, and I'm going to change it. Today it's set to basically run 1 instance of this thing. So I'm going to say, hey, why don't you give me a couple of these things? I don't need 6. Let's do 4. And I can set the min and max. I can say, hey, I want to scale between 1 and 4, but I'm just going to change it. I want 4 all the time. So I'll click create. You can see the revisions being deployed, and just that fast, I scaled from 1 instance to 4 instances. Now, let's go try this app again and see what happens. There we go, successfully deployed. We should be good to go. And I'm going to start searching again. Uh-oh, blew up. So why did this happen? ASP.NET Core is designed to be secure all the time. And so anytime it makes a post, it puts an encryption on these requests. If you're running a SignalR backend or a Blazor application, we're doing the same kinds of encryptions for the talking between the back end and the front end of those applications. And so what happened here is in container apps, I didn't have any place to store that key. And so as the app moved from one machine to another machine, it got an encryption error. I can go into my container app. I can scroll down the logs. Can close this pop-up. And I've got a history here of some of the queries I've already run before. I ran a query looking for exceptions, and I can see some exceptions here. And if I look down here, you can see it's a cryptographic exception. This is showing me the anti-forgery. This is showing that .NET doesn't like the fact that it has no place to store this stuff. And so once again, I'm not going to do all the coding on stage for you, but I've got another great article that we just published recently, just updated it this morning, actually. And this is about scaling ASP.NET Core apps in Azure Container Apps. To make this actually work, what I need is a couple things. I need to create a, let's go back to my dashboard here. Yep. And you're going to notice in my dashboard, I've got a couple of things here. I've got a key vault. That's a place where I store all my credentials because I don't want my app to have any credentials in it at all. And I've got a storage account. The storage account's where we're going to store the cryptographic keys to make ASP.NET work in a hyperscale environment. This is required for AKS. This is required for Azure Container Apps as well. So let's go back to my app. And what I've done is I've already done this in the portal. Is I created the storage app, the container app I just showed you, the storage service. I've created the key vault, and they're ready to go. I used a feature called Service Connector, which wires these things securely to your container app, which means, once again, as I said, I don't want any keys or any stuff in there. I just want it to work. And all I've got to do in my ASP.NET application is make a couple of quick changes. So let's go here. And in my app, let's go into the program.cs. And first off, I have a couple of NuGet packages I added behind the scenes. If I go and open this and go into packages, and let's just scroll this over here, you're going to see that I added some data protection NuGets for blobs and for keys and Azure Identity. That's all the crypto stuff we need to make this work. And the article is going to explain how to hook all that stuff up. And then all I've got to do is go to my application and add a couple of lines of code, and I'll kind of explain what these are doing. Basically, this says, go get the URI out of my config. My config is right over here. I feel safe showing you this because I'm using managed identity for all my security, which means there's no passwords, there's nothing in here. You could take these URLs, you can't do anything with them. Totally safe for me to put in GitHub or anywhere else. And you can see I've got a blob storage that points to my blob storage service, and I've got my key vault points to my key vault. So those are just two URIs that I've got created. My code just goes and grabs those two configuration strings, and then it calls add data protection and says persist to storage and persist and protect with key vault. So it's doing all the right security stuff. And now my application is ready to be hyperscaled in container apps or in AKS. So all I've got to do is take this application and republish it.
And while that's publishing, we have a great question here. What are the main differences between an Azure web app using a container and an Azure container app? That's a really great question. With an Azure web app that's running inside of a container, you can pretty much run anything you want out there on it. And one of the nice things is we have a team called Oryx that actually does all those images for you. It makes life easy for you to build your image. You don't have to worry about it as much as you'd have to in the past. With Azure Container Apps, it's almost like a managed container service. So you don't have the complexity of something like Kubernetes, but you get the capability of being able to have one machine talk to another machine, as well as the capability of having maybe something on the front that receives ingress and then something on the back that you can access. I'll show you that later on too.
Yeah, I feel like another cool thing just to call out here and highlight is we saw a lot of customers in app service that really loved the capabilities, but when it came to distributed applications, microservices, they typically didn't scale well in an app service plan, right? They wanted to get more granular scale, more opportunity to really manage their services in an independent way. And so I think Container Apps really focuses on that microservices scenario, and that's one of the big differentiators there is you get that scale that you're probably looking for that maybe is a little bit more arduous in a web app.
Yeah, we hope to bring more of the web app features to container apps as well. So, we already brought a few of them over already,
yep.
But we're going to bring more of them over. It really is you want to run containers, you want to run Kubernetes, but I think Kendall really nailed it. If you run an app service, there's a scale limit. You can't scale super big in an app service. In container apps, you can scale crazy. Back to your kind of a cloud native thing. Mm-hmm. So here we are. I've hooked data protection up in my application. And now, if I type Azure in and press search, now it works perfectly. I'm running in 4 replicas in the cloud. You also saw I booted up from 1 to 4 in like 5 seconds. It scales very quickly as well, so it's pretty cool. So this is just showing you some basics about how to take a .NET application, make it resilient using Poly, and then how to make a .NET application scalable inside of AKS or container apps. And with that, I will hand it over to Brady to do the crazier demos.
Crazier demos. Red button?
Yep.
Thank you. Thanks a lot. And we have another question here. Why do we need a blob to store the key and not just Vault? You can use Key Vault to store everything, but in the case that we're showing you, it's kind of the convention. You would use blob storage, and it literally puts a file in there called keys.xml, and it's got all the keys for the machines. If you've done things with IIS, it's kind of like your machine keys, if you remember those days. App Service takes care of that for you, essentially. So this is where you have to do it yourself inside of containers. But the Key Vault basically encrypts that file inside of that storage. Hopefully that answers that question okay. Cool. So Kendall's going to set up now next to me, and I want to go ahead and get started. Thanks, Scott. Thanks, Scott. Cool. All right, so what I'm going to show you first is kind of, I was tiptoeing into Dapper, which you probably heard Donovan talk about earlier, and you're going to hear Kendall talk about quite a bit later on today. I'm very new to Dapper, and one of the things that I like about it is that folks like Kendall tell me that I can just kind of dip my toes into it as I need to. Now, I'm not a Node person, but I wanted to create this selfie app. That's a tip. You should get your phones out. This will be an interactive demo. Please don't get me fired. I'm going to go ahead and open up routes. You'll see here, upload JS. Now, in this case, I literally took the code from the Learn module on how to upload an image to blob storage using Node.js. Because as you know, I'm on the .NET team. I can barely spell Node.js. So I wanted to just take that code and kind of get started with it and then add Dapper to it. Kendall said I didn't do it right. I know that. But the nice thing is you can just kind of get started. So all this code was already in the file. The Dapper part essentially is right here. And what I'm doing with Dapper in this particular case is I'm going to send a message to a back-end application, you guessed it, written in .NET. So what I'm kind of doing here is I'm using Node on the front end, and I'm using .NET on the back end. I'll show you why here in a moment. So I'm going to flip out of this, but before I do, I want to tell you a little bit about this new CLI tool that we have called the Azure Developer CLI, or you'll probably hear me call it as AZD. So what I'll show you first is that with AZD, I've got this Azure YAML file. You can see that I've got, this is my Ignite Selfies app. You'll see that the first one is that Node app that I just showed you, where I just kind of pointed at this folder. I tell it it's a JS app, and I want to store it in a container app. And then this module publisher lives inside of my infra folder right here. So this is actually my publisher bicep. So what you'll see here is this Azure YAML file just kind of lists all the different services that I've got. And these other two services, as you'll see, they're in .NET. So I'm going to flip over to Visual Studio, because that's where I do things. While I'm talking about Bicep, a nice transition, we just added a new extension to VS. You have to kind of go to the extension gallery and install it. But there's a new extension where you can actually do all of your Bicep work directly inside of VS now. You wouldn't have to use two tools. So I do want to call that out. I just started doing this over the weekend. It's pretty fun. Now, in this code, you'll see that I have two projects here, upload subscriber, pardon me, and the scaler. Now, think about that Node app. That's what's going to be publishing messages to Dapper. And then I have a .NET code that's going to be catching those messages as they're posted to Dapper. And if I go here to my subscriber app, I'll scroll down here to, scroll a little bit out. I'm going to scroll right down here, and you'll see that I have this minimal API wired up, but I'm covering it with this topic attribute. And what that essentially says is whenever a message lands on that topic, Dapper is going to call this API method. So this is a case where you're actually using minimal APIs and a microservice kind of topology. Now, you'll see right here that I'm calling grainFactory.getGrain. Now, I'm using Orleans in this application. Orleans is something that came out of Microsoft Research. It's got a virtual actor pattern inside of it. And the idea behind Orleans is it's your distributed primitive, if you will, for .NET. You can create these objects called grains, and they float around inside of any machines in your backend. Those machines are called silos. Grains in the silo. It's kind of annoying we called it a cluster instead of a farm. It's a different conversation.
You know, Orleans You know, imagine the sample I just showed before. I scaled my app to 4 instances.
Yep.
So in Brady's case, he can create an object in .NET on instance 1, and then on instance 4, I can go and say, give me that object, and I'll get the object. So you can now share objects across all your .NETs. Yep. And so that's how distributed computing works. That's how scale works. And so it's a big part of scaling .NET. Yep. And it powers things like Halo and other parts
it does.
of...
It does. It powers Halo. It powers a lot of the things in AAD. There's some Azure services that are built on top of it. There are a lot of private companies I can't name here. But Orleans is really great if you need to get to really hyperscale, you know, scaling things out horizontally. It's great for enabling horizontal scale in your .NET applications, and it makes it a lot easier. So put it that way. Now, speaking of scale, there's this other thing we've talked about a little bit called CADA. Y'all heard of CADA? Show of hands. It's the idea of being able to automatically scale your application out based on something. So CADA has a lot of built-in scalers. There's an Azure storage one. There's a service bus one. Give me some more. What other CADA scalers are there?
What? I heard one, Kafka.
Kafka. There's a Kafka one. What else? ACTP. Yeah. There's a bunch. But there's another one that I like a lot. It's called the external scaler. And the idea behind the external scaler is it's a proto file. So this is the proto file that I actually got from Kada.io, and I created a proto project, a gRPC project inside of ASP.NET Core. And what I did was I wrote this scalar service that basically implements that scalar process. Now, what does that mean in terms of your application? What I'll do here is I'll show you this subscriber. Now, I don't necessarily need to scale the front end out. It's just going to be taking images and upload them. It's the processing of those images that's going to take a little bit of time. So I'm going to want to scale that out. If I scroll down in my bicep here, I have to thank you and your team for this. It's wonderful. But if you see here before, I had my application set to scale min and max of 1. And that's not good enough because my app is going to take on a lot of users. And when it takes on a lot of users, I want it to scale out. Now, I'm being a little aggressive, and essentially what this says is I want you to look for a grain in the silo or in the cluster on any of the machines in the cluster called selfie user. That represents a user in the system, somebody who's actually connected to the system. And whenever we get to 10 users, I want you to scale out. Now, don't panic. I'm only going to scale to 10. I know it should probably be more like 1,000 or 10,000, but you know, I just wanted to do it quickly. So really what I'll do now is open up my web browser, and the first thing I'll show you is the selfies dashboard, which is right here. And this is my Orleans dashboard. If you scroll in just a little bit, zoom in rather, you see here that I've got 2 active silos. Now, I'll leave this screen up for a minute. See here that this one's prefaced with the word silo. That's because that's my subscriber project that you saw on .NET. And you also see this one is called scalar. Now what you'll see here, remember how Scott talked about your grains can just live in a silo? You'll see here that this silo has 1 activation, and this one has none. The scalar won't actually host any objects. Its job is really just to scale the other one. So if I go over here to grains, you'll see here's the selfie server directory, so that whenever I add another instance, it'll actually be able to bounce out to all my SignalR hubs. At this point, I'll open up my selfie app, which is right here. And you'll see there's the first selfie. And this is kind of what I want y'all to do. I'll show you real quick. I want to go to the ACA that I'm going to share with you real quick. Hopefully this will work.
Hurry, check your hair and everything.
Yeah.
So you're about to have to post a picture.
It's
important.
No, we're going to take a... Okay, see if it works? That's great. It's not supposed to be perfect. So I'll upload that. Let's see if it does the SignalR dance. But you'll see here that I've got 2 here. Oh, just spit on my screen. I've got 2 here. This is disconnected. For whatever reason, it's not refreshing, which is, of course, going to happen because I'm on stage. But what I want to do now is pull up the URL that you're going to hit for me, and you'll help me scale this out. So I want to give you the URL, .ms. Again, please post only selfies. Don't get me fired. So it's aka ms / ignite-selfies, and we're probably not going to see it update for whatever reason, but that's not what's super important is your images popping up here. What I want you to see is over here when I go to the silos, and I can help you rush it a little bit by clicking here. Oh, there we go. So somebody's doing what I was getting ready to do, and just control clicking, and you'll see if I go to grains See that there's that selfie user, there's that the selfie server directory. That's the one that doesn't do anything. You can even see the methods getting called in all those silos in the back end. If I go over here to the silos, we do this. Oh, we're starting to scale. So see what's happening? As you're logging into the app, Kata is going, oh, there's 10 more, there's 10 more, there's 10 more. I'm going to start to scale out individually. It will also scale back down later. It takes about 5 to 10 minutes to scale back down. But as you sign in, it's going to scale up. Cool. That's a little bit of scaling out on ACA. I want to hand it off to you now.
Wow, that was a transition right there. I wasn't ready for that. Let's make
Sorry.
some noise.
Cool.
Oh, we're
Excellent.
good. How's everybody doing? Doing good? Okay. Having fun? Awesome. No feedback? We're good. Appreciate the few woos. I'm a woo girl. So nice to meet all of you. Happy to be here. I want to cover just a few different things. Oh, you're on my screen now. That's amazing. I just want to cover a few different things. Some of the things we're investing in Azure Container Ops. We're going to cover a little bit about Dapper. Did anybody go to Donovan's session before this? I'm not him. I know. We're all disappointed. But I'll try to do him justice and talk a little bit about how you can run Dapper-enabled microservices on top of Azure Container Ops and hopefully abstract away some of the complexity of running that in AKS or even locally on, on virtual machines. So just wanted to show you, I have a quick Album API. This is basically just a back-end minimal API running, C#, super basic. I can do a quick run locally. This is not Dapper-enabled, by the way. And I just want to show the app up and running, and hopefully, fingers crossed. Y'all, my computer absolutely crapped out last week. This is a backup, and it also, the mouse pad doesn't work. So I've been carrying this mouse around. If you saw me all day, I was on the airplane, using my leg. It's really good stuff. So we're going to see, oh, nope, not going to run. That's good. Let's see. Okay, let me just close out some windows here. I think this is just transient, and we'll run that one more time. Don't save. All right, but my objective here is basically just to show you a pretty basic application running on my local machine. So we're going to pull that up one more time. And once we get this up and running, like I said, it's just going to return a list of albums, essentially, a static list. It's not using any kind of state store. It's not using any kind of storage account. It's as basic as it gets. We're going to try this one more time and just see if my machine will bear with me. All right, fingers crossed. Looks good. All right, we're cooking with gas. So you can see here, I've got my Album API endpoint up and running, and yes, I did just download Zoom It in the back whenever I saw him use it. So thanks, Scott, for that. Mark Rusinovich would be proud. If I hit this endpoint, we're just going to see it returns a list of albums. Super basic, really fun. Shout out to Craig Shoemaker, who works at Microsoft. He helped me come up with container app-specific album names. So no copywriting issues there. Okay, so container apps, super fun. If you've played with it, it's great, but you do have to provision a few things in order to get your app up and running. You have to provision a container apps environment. Right now, we actually have you provision a log analytics workspace, which is essentially going to be the backing store for all of your logs. And then we have a couple of other things you can do optionally, like App Insights if you're using Dapper, which helps you get distributed tracing between applications running in the same environment. So one of the things that we've invested in recently, I know that Brady talked a little bit about Oryx, but we're actually working with the Oryx team to make it basically a single command that you can run and get your application up and running in container apps with TLS, ingress, all of that set up for you, and absolutely no other provisioning steps. Do y'all think I can do it in one? Okay, and in addition, I'm gonna make things interesting. I'm gonna take a look at this source repository, and you can see I actually have a Docker file that's already sitting here. Now, it's a fairly basic Docker file, and obviously VS Code has great Docker tooling, but I'm just gonna delete it. And I'm just gonna delete it altogether, and we're gonna see if I can still get it up and running using the new Oryx capabilities. So I'm awesome, but I don't have everything memorized, so I am going to use a little command that I have here, and I'll walk through what it's actually doing. But we'll take a quick look here. What's neat is I can pass in a source that's either a GitHub repository or oh, nice. Or something that's running on my local machine. So you can see here, I'm doing AZ container app up. I'm passing in the name that I want to create. In this case, it's Album API. Passing in the source, which in this case, I'm actually, for this command, I'm actually pointing at the GitHub repo where this code is sitting. Once again, could point the source directly to the code repo sitting on my local machine. I'm passing in the location of the Docker file, giving it a resource group name. You don't have to do that. I chose to do that because I wanted the name to be a little bit more descriptive. And then I'm also passing in the name of the container apps and environments. And you can see here within this same command, I can also expose it externally and give it a target port so that my application will be up and running on the public internet. So we're going to run this command, and we're going to see container apps in action in a single command. So right here, you see a resource group is being created. You see a log analytics workspace. You see a container apps environment. So in a few minutes, I'm going to pull up the fully created resource group, and I'm just going to go straight to the FQDN on the application and show you how simple and easy that is. So once again, the code I've started with is pretty basic. It's just a minimal API that goes and basically returns a static list of albums. Cool, not that cool. So we're going to take it up a level if that's cool with y'all, and we're actually going to bring a little bit more complexity into this scenario. So it's great that container apps can help me get up and running quickly with AZ Container App Up. We've also been working on an extension for those of you who are familiar with Docker Compose. We don't support native Docker Compose translation in container apps, but some great friends at Microsoft contributed a Docker Compose to ACA translation that we've added into our CLI as an extension. So if you're used to using that for local development and basically want to translate that directly into a container apps manifest using Bicep or ARM, we've got that good to go for you. So in this case, we're going to switch over, and now we're going to look at container apps Dapper Albums application. So this is more of an end-to-end solution with two different microservices. So one of them is going to be a front-end application that's just basically calling the back-end API to retrieve a list of albums. This time we're going to get a little bit more complex. Oh, so crazy. We're not going to just return a static list. We're going to return a list of albums sitting in storage. So this application is fully Dapper instrumented. For those of you who are new to Dapper, how many people haven't really played around with Dapper themselves? Okay, so like a decent number of people. It's a somewhat new concept. So what I would do in order to basically get Dapper initialized is run this Dapper init command. When I do that, one of the really cool things that Dapper does, not only does it install all of the, the binaries and everything I need on my machine, but it also deploys these two local containers. So you'll see here I have a Redis container. I have a Dapper zip placement container, which is basically used specifically for using Dapper actors. I have a Zipkin container where if you were in Donovan's session, that's used for local distributed tracing in Dapper. And we also have a local Redis. What Dapper allows us to do is essentially use Redis in a container as a local state store and a local pub sub mechanism. So I'm going to show you all the app running locally, and then I'm actually going to show you how you can deploy something similar to container apps. Is anybody a fan of container apps or started using it yet? Okay. All right, so I have some people to convert, it seems. One of the big asks has been support for protocols outside of HTTP, like UDP, TCP. I'm excited to announce that coming very soon, we have TCP support. So today, I'm actually going to show that to you as part of this demonstration. But hey, before we jump into running this locally, why don't we switch over and see if our album API is up and running? So it looks like right now what's happening is it's actually going through and creating an ACR task. So, as you know, I deleted the Docker file. So what this is doing is it's actually provisioning a container registry in Azure, and then it's going to use Oryx to essentially identify what the Docker file should look like, and then it's going to push that as an image to container registry. So that's what's happening in this output. What we should see at the end of this is not only a successful image build. Fingers crossed, it looks like a lot of red. Okay, it looks like it's working. We'll also see that get deployed. So we'll come back in just 1 second. Now, once you see what all it's deploying, you'll understand why it takes a little bit of time. But we'll go back and we'll run this other application locally. So I use VS Code tasks, which make it really, really easy to do local development with Docker. So if I do a quick run, fingers crossed, what this will do is actually launch both the front end and the back end albums API. And it's also going to launch the Dapper sidecars and put it in a way that looks visually appealing for all of us. So it looks like it's working. Amazing. All right, so we see we now have output from 2 different applications, both running using Dapper locally. So let's take a quick look at the terminal. Once again, for those of you who are new to Dapper, I just want to call out a couple of things that I want to highlight. So first and foremost, I have a front-end node application, and we can see here that Dapper is getting instantiated basically because we did a Dapper run. We passed in some information that basically tells us, hey, Dapper, talk to my application on port 3000. That's where the front-end application is running. And then we also pass in some information about the port on which the Dapper sidecar itself is running. So in this case, the HTTP port 3180. As it's loading up, the biggest key to Dapper and getting it running well is making sure that your components are loaded. So you can see here, I loaded the PubSub component, which remember I get out of the box whenever I do the Dapper installation. And then I also have a state store. That means that basically I can start interacting with Dapper and offloading the responsibility from my app to go store and retrieve those albums to this local Redis container that's essentially running on my local machine. So it says applications discovered on port 3000 because we told it what port our container was running on, or excuse me, our app was running on, and it's all good to go. And same thing on the order service side, it's all up and running, and we should be good to go. So let's take a look at the actual album. We'll go to Microsoft Edge. And what's funny is I think it's running on the same port as the other one, but hopefully I stopped that app. Okay, so we've got our application up and running, and you can see here that we loaded our albums from the backend API. So you can see here I invoked the album API via Dapper, and on the backend side, you can see that 6 albums were retrieved from the state store. I want to show you just how simple the code is in the album API, just for context here. I was a developer, for the first 1 or 2 years I was at Microsoft, and I haven't really written much code since, not gonna lie, I know, disappointing. However, I can write with Dapper easily. That's the nice thing. So what's really, really cool here is basically when I hit that album's endpoint, it only takes 1 single line for me to go retrieve Dapper state. So instead of wiring up any code to do with Azure Storage, any code to do with Redis, I literally instrument it with 1 line of code using the Dapper client. Once I get that, I can basically say, hey, are there any albums? If not, go ahead and seed the database, which is happening here. And then I basically just perform another get. So if we take a look locally at this Dapper state store, so essentially all this is a Redis viewer for the locally running container on my machine. And we can see here that we actually have that album API greatest hits. And if I take a look, we can see that that data is in fact sitting in this local Redis instance, right? That's all I had to do in order to basically seed and retrieve data locally. Okay, cool. Do you want to see if the output from the other one came back? Take a quick break here. Okay, awesome. Looks like the app's up and running. I'm going to do a quick poke, and we're going to see that basically without anything else, the app is up and running. Can we get a clap for that? That's pretty impressive. I'm impressed. I might be biased just a little bit, but I'm impressed. Okay, so let's go ahead and take a look at the Azure portal, because we're about to also go through the process of getting our Dapper albums microservice sample up and running. But first, we'll take a quick look. I have my resource groups, and if you can't tell, I've been creating a lot of them the past few days. And we can see that let's see, what did I call it? I don't even remember the name of the resource group I gave it. I'm going to be completely honest with all of you. Let's see. I'm going to go back to this. Thanks for bearing with me. All right, I called the resource group Ignite albums. Amazing, simple, easy. Okay, so we'll click in on Ignite albums, and what we can see is this is what got created for us. So we got the Log Analytics workspace, we got our albums environment that's hosting our API, and we also got that ACR instance. And if I look at the ACR tasks, I can see that this is actually what went from my source code in GitHub to actually build that container app. So that's all cool and dandy. We have this local experience that I've showed you with Dapper. How about we get this up and running in container apps? And I'm going to do one more cool thing, which is essentially I'm going to actually create a Dapper component to point at Redis, but that Redis is going to be running locally in Azure Container Apps using the TCP protocol. So what's cool about this is ideally we're not running Redis inside of container apps, but the fact that we have TCP support goes beyond just supporting Redis for test instances. You can now scale based on concurrent TCP connections from an external perspective. So there's obviously a lot more use cases than just what I'm going to show you here. But I do want to show you a few things. So I'm going to close this out. I have a lot of deployment scripts on how I got some of the supporting resources up and running, and I just want to kind of show that to you really briefly. So we'll look at this infrastructure deployment script just to kind of show you essentially what I deployed before this demo. So you can see here that I basically have a few different things going on. One of them is my Azure Container Registry. So in this case, I'm actually creating and provisioning a container registry up front. And in addition, what's really nice is that we do, this is one thing that's been buried in some of the container app stocks. We support using ACR pool to authenticate and pool your images into container apps. So I went ahead and created a user-assigned identity that could be used in order to connect to container registry. I also have a couple of other modules, right? One of them is that container apps module. In this case, for TCP, I'm actually deploying into a VNet. I can deploy into a VNet with either no public IP address, or I can deploy into a VNet that has an external IP address. So that's just something to keep in mind. And then you can see there's a couple of other supporting resources in the mix that weren't there before. So one of them is going to be Azure Storage. I'm going to show you in just a second how I can basically run this local Redis instance and swap out the Dapper component to point at Azure Storage, and use Dapper secrets because we recently provided support for that, i.e. that launched today. And then we have a couple of other Dapper components. So all of that's basically being provisioned already using this bicep template and a few modules. But what I want to show you is the actual deployment of the Redis itself. So we saw the album API, we saw the album viewer, but what I'm going to do here, and once again, I'm great, but I'm not great from a memory perspective. So I am going to use some of these deployment scripts just to show you a few different things. So one of them is going to be, the first thing I'm going to do is we already went and created the resource group. We used the templates to go through and actually provision the supporting resources. But now I'm going to create the Redis container app. Now, we support local CLI. We also support using YAML manifests. So for some people, you're like, get me away from YAML. I don't want to use this ever again. Totally fine. How am I doing on time? Do I get the rest of that time? Okay, I'm going to take it. Okay, so I'm gonna deploy this Redis using a local YAML file, and I'm just going to pull it up to show you what it looks like. So here's the container app itself. I'm basically providing some information about the name of the container app, the managed environments, and then I'm also passing in some new ingress information. So one of them is I want the transport to be TCP, and I want this Redis container app to basically expose port 6379. I'm using a public image. I know this is like taboo. It's a demo. Don't, go with it. And then I'm also setting the min replicas to 1 because I don't want it scaling down to 0. So should be able to deploy this pretty quickly. I'm going to do that, pretty fast here. Let me just move into the appropriate folder.
While you're doing that, I'll. Can I write container apps in any language like TypeScript or Go? Yes.
Yes. If it can run in a container with some, y'all, this is so fun. We love this for me. Just give me 1 second. I think I actually, how about this? I have it up and running. Are we cool? I'm running out of time. Are we cool to just see it? Okay. Yeah. I promise it works. I only practiced it 350 times. Okay, so we're just going to show it up and running because I am prepared. So here's an example of kind of a dev scenario where I'm running Redis inside of the container apps environment. So you can see here, if we do a quick look at the deployment itself, and I actually like this resource visualizer because I feel like it just puts it all in context. We've got 1 minute and 50 seconds. Can I get a cheer? Can I get a cheer really quick? We're going to see it. It's going to happen. Okay, I have 3 container apps running in a container apps environment that's VNet integrated. You can see them running here. What's super, super cool is, once again, didn't change any of my code. And essentially all I did, I can go into this Dapper Albums Redis test. I'm going to show you the log stream, just so you believe me that Redis is up and running and everything's good. In addition to that, I could easily go into the console connect experience and run the Redis CLI. So fun, so great. We love that. And then I want to show you the album API and what's happening here. So I have Dapper enabled on the album API, and I also have this state store called state.redis. If I take a look at that, all it's doing is pointing to that local instance of Redis running in the container apps environment. Love that. Awesome. Woo. Okay, so we've already seen the album API. We know what it can do.
A little bit.
Oh,
it's a little tiny.
Oh,
she only has 50 seconds, Scott. Shh.
Oh, no,
Okay.
We're good. We're good on time. Okay, you're going to see it running, though. and you're going to see that it's retrieving these albums directly from Redis. The reason why it's taking a little bit to load, I scaled down to 0. We love cost savings when we don't need it, don't we? Okay, cool. Last thing, I got 40 seconds. Now we swapped it out. That Dapper state store is now pointing at an Azure storage account. Even better, it's using managed identity and key vault using Dapper. We love to see that. All of this is publicly available. Last thing though, okay, I want to show you the, let's see, I'm trying to think. I'll show you the component. Oh, album viewer's running, getting it from Redis, snaps. We love that. And then the last thing I'm going to show you is basically all I did from a Dapper component perspective. I added a secret store to connect to the Azure storage account, and then I created this state store that's now pointing at blob storage. And all of a sudden, our app is running. Awesome. Yeah, thank you. Appreciate that.
Thank you, folks.
Yeah, thank you. Thank you so much.
Great work. Awesome.
And for the people in the room, there is a question that says, is this an MS answer to Kubernetes? What we're showing you is how you can use Kubernetes easier is what I would say. So we're showing you how you can do builds without having Docker files. We're showing you how you can run containers on Kubernetes without having to manage Kubernetes. That's really what we're showing.
There's the one from Azure Storage.
All right. Thank you, everybody. Thank you.
Thank you.
Thank you, folks.